This one is page 20. The next doubt is from page 27. Page 27 that we did. Then 30. Okay, page 30 is actually related to the whole question is there starting at page 28. An athlete, as you can see, an athlete is there. Athlete bend his knees and then spring up into a vertical jump. The graph below shows how the reaction force from the ground on athlete varies. First, as you can see, the diagram below shows the position of an athlete correspond to a time as he jumps. You can see when he's standing straight, stationary, like he does not change the orientation, that time the weight is equals to the normal contact force. Then what happened as he bent his knees, the position of the center of mass changed. That's why the downward force has changed. Like why it has decreased here, as there will be like the position here, the weight was passing. This is a reaction force. So this is a point where he experienced the reaction force. But as you can see, the weight is not in line with the normal contact force. That's why the normal contact force has decreased. And as he is pushing the ground, the moment he pushed the ground, there is more upward force than the downward force. Like he will have a resultant force with reference to the earth. That's why he accelerates upward. And as he jumps, he's not having any contact with the ground. So there's no normal contact force, this region. And then he lands again. You can see a similar pattern graph is there. So this point, the weight is balances with the normal contact force. R is equals to W. And this time, this is R. And what about the resultant force? It will be R minus W is equals to F. So show that the mass of an athlete is about 80 kilogram. How we can show that mass is about 80 kilogram? At this point, the weight balances with the normal contact force. So we can say weight is equals to R. And weight is mg, so mg is equals to R. What about R? Like this one is each box 1, 2, 3, 4. So each box is representing 50 or 100, sorry. So this is 600, 700 and 750. This is 750 into 9.81. The normal contact is 750. So 750. This is gravity 9.81. Mass we want to find. So this will go there in division. So it will be 750 divided by 9.81. So when 750 divided by 9.81, we'll get the mass of this athlete, which is about 76.5. Which is about 80, 76.5 kg. Then a small dot on each diagram of an athlete represents his center of the gravity. What's it meant by center of the gravity? The definition, it's a point or a position where whole weight of an object act, or a force of a gravity act, you can also say. Between 0.2 seconds to 0.7 seconds, the athlete bends his knees. As a result, the center of the gravity moves lower. Explain how the graph shows the acceleration, then explain how the graph shows that acceleration is produced as an athlete bends his knees. So how the graph shows that as he bends his knees, as you can see, we already calculated initially the weight of this is the weight of the athlete, because this is a point where he standing straight. So here, what happened, like example, this is 750 Newton, the weight, and the normal contact is 750. But as he bends his knee, his weight is not changing. Only the position of the center of the gravity has changed. So with reference to Earth, like when we compare, an athlete is there and the athlete is bending the knees. So the gravitational force which he experienced was 750 Newton, and the pair force, he's also pulling the earth by the same force, but in opposite direction. Now, as his center of the center of the gravity has changed, so less downward force is there. The downward force is about you can see one box, so it's about 100 now. So now as he bend his knees, the downward force by him on the ground is 100. So if the downward force is 100, what will the upward force? The upward force is also 100. So with reference to the earth, there is more downward force than the upward force. So that's why he will accelerate. Or you can also say, as you can see, when he is bending the knees, the reaction force is smaller than the weight. So there will be a resultant force downward, or there will be an acceleration down. Or forces are not balanced. Then what happened? In order to jump, an athlete pushes the ground from 0.75 seconds to 1.05 seconds. With reference to Newton law, explain why the athlete must push the ground. So why the athlete must push the ground? So we have to create, because to move or to jump, we want a resultant force upward. The weight of the athlete, which is 750 Newton, as an athlete apply a more downward force. Like example, an athlete apply say 100 Newton, or how much reaction force is there? It's about 2,500 is a not reaction force. Or 2,000. So the total downward force is equals to weight plus the extra force which an athlete applied. So 750 Newton was the weight plus the extra force which an athlete as he pushed the ground. So he applied because the total force is 2,500. So it's about 1,750 should apply a downward force. 1,750 Newton example, he apply a downward force. This is a force from athlete. So how much is a normal contact force according to Newton pair force? If the total downward force is 2,500, the total upward force will also be 2,500. But when we check with reference to the earth, that this force now, the force as the ground is applying an upward force of 2,500 Newton, this force is more than the weight. So as a result, the forces are unbalanced. That's why this athlete will accelerate upward. So you have to mention, as an athlete apply a downward force according to Newton's third law, there will be equal but opposite upward force, and that upward force will be greater than the weight. That's why the athlete will accelerate upward, and acceleration is proportional to the resultant force according to the Newton's second law. The next part, the maximum reaction force was reached at 0.9 second. Calculate the acceleration of an athlete. So this is a maximum reaction force. And what about the resultant force? Because we want to calculate the acceleration of an athlete, the reaction force is more than the weight. So reaction force minus weight is equals to ma. So reaction force, we have to use the graph. It's about like 2,450. It's between 2,400 and 500. So the normal contact force is 2,450 minus the weight was 750 is equals to m, which we already calculated in the first part, and a. We simplify to calculate the acceleration, which is 22.2 meter per second square. The athlete was in air for 0.5 seconds. Calculate the height jumped by the athlete. So we want to calculate how high the, like he will change position or his center of the mass. So if we have the time, because if an object is moving under the influence of a gravity, so it will have an acceleration, and that acceleration is due to gravity. So we just have to calculate the height of the calculate the height jumped by an athlete, and he was in air for 0.5 seconds. About half second he was in air. As you can see from 1.01 to 1.51. This duration, which is 0.5 second, he was in air. So we can use the equation of the motion to work out the maximum height, and we consider the acceleration will be equal to the. So if he was 0.5 second, he was in air. So it means he will take 0.2, because half of the time he will take to reach the maximum height, and half of the time he will take to come down. So it will take like 0.25 seconds to go up and 0.25 seconds to return back. And he will have an acceleration now, which is due to gravity, because he is not in contact with the surface. So his acceleration will be equal to gravity. So if I take the second part of the motion, when he's coming down, so I can say initial velocity will be 0. Acceleration will be equal to due to gravity, which is 9.81. And I have the time, so I can use equation of motion. So for second half I took. So I took S is equals to ut plus half at square, in which the initial velocity is 0. So S is equals to half, this u will be 0, so this factor is 0. So half gt square. So it will be half, the gravity is 9.81 and the time is 0.25 square. So when we simplify this, we'll get the maximum height. Basically, it's like we take the half of the motion from how much time he's taking to fall from the maximum height. So we work out its maximum height, which is 0.3 of the meter. Is it clear, this part? You can also take the first part of the motion. Reason why I did not take the first part, because if I want to take the first part, the final speed is 0. Then first I have to find initial speed, and then from initial speed, I have to find the time. I have to find the displacement. Like initial speed won't be 0, acceleration will be due to gravity. I have the time. So first I'll find the initial speed, and from initial speed, I have to work out, like I have to find two things. First the initial speed and then the displacement. But if I take the second half of the motion, I just have to find the displacement directly in which the initial velocity is 0. That's why. Just to make it simple. Otherwise, if you want to do in two steps. You first find initial speed by using a formula V is equals to U plus AT. You work out the initial speed, and after working out the initial speed, you substitute in the formula and get the answer. In that case, you will substitute acceleration negative because it's against the gravity. So it won't make difference to the final answer. Just to make it simple, like to solve in 1/7 of 2 mark question, that's why we did not use two formulas. Calculate the speed of an athlete on now this part. Even if you did like example here, so you don't have to do it again. Now you need to calculate the speed of an athlete on leaving. So you can just find, if you know the here two ways you can use the gravitational potential energy equals to kinetic energy, or you can also use the same concept that if you have the time, you find the initial speed. Like as I mentioned, if it is going up, you need the initial speed. The final speed is 0. It is due to gravity minus 9.81 meter per second square, and the time you'll take 0.25 seconds. So just use equation of motion V is equals to U plus AT and work out the initial speed from this. Or you can also use the gravitational potential energy is equals to kinetic energy. So mgh equals to half mv square. M will cancel with m. So gh is equals to half v square. You can also use this formula. As I did not mention, there's a loss of energy. The next is question page. This was page number 30 and then 34. A student has two magnets, A and B. A magnet A is smaller and a weaker than a magnet B. The weight of a magnet A is determined by using a digital spring balance, and the weight of a magnet B is determined by using a top pen balance. Magnet A is moved to a position above magnet B, and there is an attractive force because unlike poles are facing. And the reading on the two balances change. Look here, the weight is acting downward. Here also the weight is acting downward. And they have a different weights. But when they're like according to Newton pair force, Newton third law, there are pair forces. If I just use a value, like example, I say this is 2 Newton, this was 5 Newtons. And with reference to the Newton pair force, as they're trying to attract each other, so magnet A will be pulled down and the magnet A is being pulled up. Say this force is equals to 1 Newton and 1 Newton. So what happened to the reading on the balance for a magnet A? Already its weight was 2 Newton downward and there is a force of attraction of 1 Newton downward. So as a result, the reading on this balance will increase because its weight is acting downward and there's a magnetic force also acting downward. So reading will increase. But what will happen for this one? There's a weight 5 Newton which was acting downward and there's an upward 1 Newton because of the gravitation, the magnetic force of the magnet. So as a result, there will be a 4 Newton resultant force. Here, the resultant force is 3 Newton. So that's why the reading on the digital spring balance will increase and the reading of the top pen balance will decrease. So you have to write in a systematic way, like the points which you should include. The first thing, according to Newton pair forces, the two magnets apply same force, but opposite in equal, same force, same equal force, opposite in direction. So the reading on the digital spring balance, why it will increase? Because there is more downward or a resultant force, greater downward force, like the force of a magnet plus its weight. That's why its reading is increasing. And the reading on the balance, the top pen balance is decreasing because the weight and the magnetic force are opposite, so which produce a smaller resultant force. So this was about the Newton's law of the motion.